All right, hello everybody. I'm about to get started with the CircuitPython Day stream. Let me just shuffle a few of my windows around here and make sure I got the chat pulled up. And make sure all of the playback streams are paused so I'm not hearing myself. All right, so to kick it off, I'll start with a quick introduction for folks that might be new. My name is Tim. I go by Foamy Guy on the Discord and on GitHub and places like that. And so in this stream, of course, in honor of CircuitPython Day, we're going to be working on CircuitPython. If you are interested in this type of stuff and you've never caught my streams before, you can catch me normally on Saturdays at this time, 10 a.m. Central Time, 11 a.m. Eastern Time. So usually that's when I'm streaming is on Saturday mornings at this time, but in honor of CircuitPython Day, we're going today. If you are brand new to this and you don't know anything about CircuitPython, I don't know how many folks that will be, but this is recorded and folks might be watching it in the future. So just as a heads up to folks that are brand new, we're going to be working on this project called CircuitPython. It's a version of Python that runs on these tiny computers called microcontrollers. Here's one of them right here. This is a PyPortal device. This one's got a nice big screen on the front, and it's actually a touch screen. This program doesn't respond to the touches, but this is a touch screen on the front. You can get the location that the finger is touching it on. You can make buttons and do all sorts of stuff like that. And CircuitPython runs on devices like these. The main computer on this device is right here. This is a SAMD51 microcontroller. And this device has a couple sensors and a speaker, and it has access to the Wi-Fi network using this ESP32 device right here. So this device is great if you want to, make something that connects to the internet and pulls some kind of data, show it on the screen, or, record some kind of data from a sensor and send it to the internet. And this is the type of device that CircuitPython is all about. There are different shapes and sizes of these microcontrollers, but the core idea are these tiny computers that you can plug in other little, bits and bobs into, little sensors and buttons and lights and all sorts of things like that. And, connect up to them and write Python code in this really, simple way of just loading the device as a thumb drive. On that thumb drive, there's going to be a code.py file right there, and you can just write your Python code right into that code.py file, and then it will run as soon as you save it. So it's much easier than some of the other ways that you can run code on microcontrollers that came before it. And so that's what we're working on. If you want to help support the CircuitPython project, there's a couple of ways you can. One of them is by contributing. It's an open source project, and anyone and everyone is allowed to contribute to the project. You can contribute by going to circuitpython.org, clicking on this contribute link right here. Oops, my PyPortal rebooted, and it caused this little thing to play music. I don't know if that's coming through the speaker, but that's what that is. You can help. I'm going to unplug it for now, actually. You can help contribute by, helping, program the language itself. You can work on the CircuitPython core if you, probably if you have more experience programming and in software development, then that's going to be something you could do. If you are new to it, don't worry though. There are also ways that you can contribute that don't quite involve, that level of depth. You can contribute to the libraries in a couple of different ways. If you come to this circuitpython.org and click contributing, you'll find a list of open pull requests. You could go through these pull requests. You could find something that you have the device for, and then you could go to that pull request and review it. You could look at the code changes, make sure there's no typos. If you have the device, you could even try running the version that's in the PR, make sure it works, test it out, and then leave feedback on that PR. So that's one way you can contribute. Another way you can contribute is by purchasing hardware from Adafruit. So this is their website, adafruit.com. They are the folks that are the primary financial backers of CircuitPython. They pay folks to work on this project full time and to foster the community and things like that. So if you purchase hardware from them, they sell the microcontrollers, they sell all sorts of sensors and bits and bobs that you can use with the microcontrollers. So by purchasing hardware from them, you are helping support the CircuitPython project. And of course, today is CircuitPython Day, and they are the ones responsible for organizing CircuitPython Day. So definitely huge thanks goes out to Adafruit, and that is the other way that you can help contribute. If you do want to get involved, you can join the Discord. Down below in the stream there is a link to the Discord. adafru.it/discord. And then for this stream in particular, we'll be in the live broadcast chat room. And I also have the Twitch chat pulled up. So how's it going there? The real time. So I will start out after the introduction here with a couple of quick thank yous to the real time and Linux 2031, both on Twitch. Those folks both followed me today, so I assume they probably found this link through the CircuitPython Day festivities, so thank you to both of you. And so let's get started. So what I'm going to work on today is some enhancements for a CircuitPython library. So we're going to be writing Python code that will ultimately go into a PR and end up in one of the libraries. And specifically, what we are working on. Oh, also, before I forget to mention, it is CircuitPython Day. There's going to be a couple of other streams today. My stream is the first one going on here. The next one is scheduled at 1 p.m. Eastern, so in about 2 hours from now is when that next stream will be. And there's links if you want to get them in that live broadcast room. If you scroll up right before my message, Jeff helped us out by posting a link in there that goes to this blog page, which has links to all the rest of the streams, as well as a link to the Reddit AMA. Hey, yeah, thank you for dropping that link in the Twitch there as well. I appreciate that. Okay, so yeah, check out the rest of the streams. I'll be wrapping up, right before that next one starts. I'll go for about 2 hours, and then I'll wrap up, and then that next stream will get going next. So the specific library I'm going to work on today is the DisplayIO layout library, and we're going to be working on the grid layout inside of that. So this is actually the docs for it. Let me go to the GitHub page. Let's see, there's probably downloads, I think. This is how I get to the GitHub page sometimes. And so this library, it's got a couple of different DisplayIO layout helpers. DisplayIO is the native display driving software, or library, I should say, module for CircuitPython. So DisplayIO makes it easy to, run programs that run on microcontrollers with screens like this PyPortal that I've got here. And specifically, we're going to be looking at the grid layout, which is a layout helper that allows you to easily put your different views, labels, images, things like that into a grid position on the screen. So let me plug in my PyPortal here, and I'll show you the basics of what that library does, and then we'll get started working on some enhancements for it. So let me just take the example code. I'll grab the example code right out of this repository, and this repository does house a couple of other DisplayIO things in it. Some of these are going to end up moving to their own repository. Some of them have moved already, but they're waiting to get finished up, and then eventually they'll get removed from here because this one we want it to just be layout helpers specifically. But there are some other neat widgets in there at this time. So I'll also drop that link. I think that'd be a good idea. Let's do that. I'll drop that link in the chat here as well if folks want to check out that library. We don't need this huge box for it though. Let's remove that. So I'm going to grab the simple test example for the grid layout, and I'm just going to copy this code. And this is how easy it is to run a CircuitPython program. I'm just going to take that code. We're going to open up CodePy. This is the mu code editor. This is the kind of primary editor that's recommended for CircuitPython. But because it's just a text file on a thumb drive, essentially, you can actually use pretty much any editor that you want. Sometimes I use PyCharm, a more fully featured IDE. But you can also just use a basic text editor and stuff like that. That works totally fine as well. And all I have to do is actually just save this code. So what I'm going to do is I'm going to switch this over to the side here. I'm going to bring back the camera. And what we're going to see is as soon as I save this code, I'm just going to save it with Control S. As soon as I save it, this device is going to reset and it's going to run the new version of the code. So now it's got this grid layout example running on it. And so you can see here it's got 4 different labels. A couple of them have background colors. A couple of them are just black in the background and white text. And so this gives you an idea of what this library or what this particular helper is all about. It's about helping you line up your different labels and images and other views into these nice square grid or table formats here. You could do this all, sort of manually. You could just figure out the right pixels, X, Y coordinates to line all this stuff up. But this library makes it really easy. You can just create a grid layout. You tell it what size you want the grid to be right here. So we set this one up to be 2 by 2. We can have some padding in between each of the cells. We have the total size of the entire grid. And then we essentially are able to just add content, right? So we are able to create labels and then just add those labels into the grid. For each label, we tell it which position within the grid we want it to be, and it will take care of figuring out the X and Y coordinates so that we don't actually have to do all of that math. Hey, yeah, thank you, Dexter. I appreciate the heads up on the audio, and yeah, for sure. I'm super happy to be streaming on CircuitPython Day today. So I'm also interested, I'll be happy to watch some of the other streams that are going on as well. So lots of other good stuff going on today. So the enhancements that we're going to be making to this library, there are actually a couple of issues that are already filed in the GitHub. And I'm going to start with this one here. This one I think will be fairly easy. The main thing that we're trying to do with this is currently, you are able to access the cell items. So in this case, it's labels, but this can hold other items as well, like images or buttons or other DisplayIO objects. You can access those things by using their index that they were added to the layout. So in this sample code, if I wanted to change the text on one of the labels after the fact, so like the text gets initialized, to have certain strings in it, so, hello world and then hello grid. And of course I could initialize it with different text in it, but let's say I had a program that ran longer over time and I wanted to be able to update the text of one of those labels. One of the ways I could do that is by accessing it by its index. So if I said layout index 0.text, I can change the text that's in that first label, the first one that we added to the grid up here. So we could change this one to say maybe CircuitPython, and maybe we could change the next one as well, label 1, to say day. And so if we save that and rerun it, I just did a Control S, so it's already saved and run. And you can see there that it did update. In this case, the label does run a little bit longer, so maybe what we could do is go Circuit in the first one and Python in the second one. Something like that, maybe. And it looks like that might fit a little bit better there. Yeah. So this is how we can, access the sub elements that are inside the grid and be able to change their properties. Of course, I've changed the text, but you could also do things like changing the color, the background color, the foreground color, any properties that exist on these objects you can actually change this way. And so this is nice. It does work, but it's not as easy as it could be because you have to know the index. You have to know the order that these things were added to the grid. So what this issue is all about is allowing us to essentially call up those DisplayIO objects using their XY cell coordinates in the grid, like being able to say, I want the item that's at 0, 0 inside the grid, or 1, 0, so on and so forth. That way you don't really have to remember or care what order they were added to the grid. You can just get them in any order, you add them in any order you want, and then you just always can access them by the position. Hey there, Lay Samurai. Lay Samurai does a lot of great work helping us out. I definitely owe big thanks to Lay Samurai helping us lately on some of the updates for CircuitPython 7. So nice to have you watching along, and thank you as always for all of the help that you provide. So, thank you to, let's see if I can catch it. I might not be quick enough. There we go. The Real Time is hosting the stream. Hey, thank you for that. I appreciate that. All right, so we will, if you are interested in this issue, you can take a look at the issue here. If you grab that link that I pasted a little while ago back to the library, and then you click on issues at the top or near the top of that GitHub page, you can see kind of the proposal that I laid out for this. And so this is what we're going to be working on. So I'm going to go ahead and open up PyCharm, because that's the editor that I use when I am working on libraries. And I'm actually going to move it real quick here, just because it probably has something else loaded up in it. I should have probably had it open before I got ready, but I was real excited to get everything running this morning, and I did not get this loaded up ahead of time. So what I'm going to do is open up the library, because I have a local copy of it already. Of course, if I didn't have a local copy, hey, thank you there, Skywatcher Jim. I appreciate the follow on Twitch there. I'm going to open up this library. This one's called DisplayIO Layout. Open that, and then I'll just bring the PyCharm window right back here, and this is where I'll be working in for most of the time here. So inside of this library, we have, what do we have all the way in here? We have the library itself, which is the Python code that encompasses all the things that are in the library. We have some documentation that gets built using a tool called Sphinx. So this creates the documentation that eventually ends up hosted on, read the docs. So like if you're on the GitHub repo, there's this docs badge right here. If you click on this, it takes you over to some documentation that shows you how to use the library, what all the things that are contained within it do, what kind of properties and functions and everything they have. So documentation is a great tool. That's another thing that's stored inside the repository. And the last thing is every CircuitPython library will have some examples in the repository. So we try to make it really easy for folks to get involved and get using a particular library by providing, examples, basic examples, advanced examples sometimes. So this is another way if you're relatively new to programming, but you want to help contribute. One of the things that you can do is write more example code for these libraries. We're pretty much always interested in having more examples for any libraries. So that's another relatively easy way folks can get involved. But today we want the grid layout. So we're going to go inside layouts, inside grid layout. And we're going to be defining a new function. So I'll start out by just making kind of the function signature here, def. I think did I call it get cell or something like that? Get element. I think maybe get cell might be a better name for it, because we call stuff cells a lot of times. Like here it says cell content, layout cells. We don't really use the term element. Element is kind of like an HTML type term. It's pretty similar idea if you're used to HTML as to what we're talking about here, but I think we'll just go with cell. Get cell, maybe we should say get cell content. I think I'll leave it with just get cell for now. So this is going to be a function. This is, I'm just going to put pass so that it will make PyCharm happy for now. This is going to take one parameter. The parameter is going to be a tuple, which will be the XY coordinates, cell coordinates. And we're going to need to have a dictionary, I think. Dictionaries are one of my favorite things about Python, because dictionaries make it easy to look stuff up based on some input values. If you think about what this function is going to do, it's going to take an input that's going to be an XY coordinate, and it's going to return back the object that is at that XY coordinate. So that is a perfect use case for a dictionary. That's exactly what dictionaries do. They take a key and they give you back a value. So we already have a cell content list. I think what we'll do is just make a dictionary as well. We can add that as a private variable inside this class. We can say self.cell dictionary. Maybe we'll change the name eventually. I think I like dictionary for right now, though. We're going to make that a dictionary by using the curly brackets right there. And then basically what we're going to do is every time we add something to the grid layout, we add it by calling this add content right here. So as soon as we append it to this list, we can just also add a mapping into the dictionary. So we can say self.cell dictionary, and the key we want to use is the grid position. So we're already getting past that tuple grid position, so we can just go ahead and use that as the key. And we're going to set the value. I'm going to set it equal to the index that it ends up in the list. And then that way the dictionary will map the XY coordinates as the keys, and the values will be the index in this cell content list. So we can get the index. We know that we just added it to the cell content list, so we can just say the length of this list. Ooh, what did we do there? Tried to run something. I'm not sure what that was. I think I hit a shortcut key or something. We know that we just added it, so we can take the length of this list and then just subtract 1. And that should be the index of the item that we just added right there. Let's see. Right. We want the length of the list, and then we want to subtract the 1 from the length. We don't want to subtract 1 from the list and then get the length of that. That wouldn't make any sense. So we'll do it that way. That might be all we need. That's going to give us the grid position as the keys. That's going to give us the index as the values. So then inside get cell right here, we can just say return. We're going to look it up out of our dictionary, self dot. Do I have an underscore there, or is it just yellow? Let's see, return self dot cell dictionary. And we want to look up the coordinates, but we don't want to return the index. We want to return the actual item, the object that's in that cell. So we will access it by looking inside of the cell content list. Content list, not test. There we go. So we access the index from our dictionary, and then once we have the index, we're going to look at that index in our list. Looks like I forgot a dot right there, so let's put that in. And also I spelled list wrong. There we go. These are some of the reasons I like PyCharm, because it will highlight my code different colors, usually when I made some sort of mistake, which is nice to know about it before I try to run it. Hey there, Keith, the EE. Hey, real quick, I appreciate you putting together the AMA. I think you had a lot to do with that, so that's going to be really cool. I'm looking forward to that. Thanks for putting that together for us. So this might just work. I think this may be all we need, honestly. So let me save this, and then let's try it out on the device. I'm going to go open this up in my File Explorer. I'm going to copy this library right here. We are going to go to the CircuitPython device, which in my case, it's a PyPortal right now. And we'll just delete the old version of this. I can always reinstall the old version if I need to. But I'm just going to paste in the new one that I just got done editing. So I just do a Control-V paste right there. Now you can see it's here. My OS is telling me that it's pasting, pasting, pasting. Eventually it will finish. As soon as it finishes, the device will go ahead and reboot automatically and run this code again. Of course, at this point, we have not, we haven't tried to use our function yet. So let's go ahead and try to do that. So maybe we could try accessing this text label down here, the bottom left one, which currently says hello. So maybe we could say layout.get cell, passing in a tuple, and that one is at, let's see, I think this goes columns and then, rows. Yeah, columns first and then rows. So we want 0, 1. We want the first column and the second row. And of course, we're 0-based indexes. So that's going to be 0, 1. And then let's go here, text equals CircuitPython. Let's put it day. And let's see if that works. Save that. Nope, dictionary object has no attribute text. Dictionary has no attribute text. So get cell. So we've done something wrong. Let's see here. Cell content list. So maybe we can add some print statements here for a little bit of debugging. I think what I'll do maybe is just go ahead and open this in Mu as well. That way we can just work on the library code right here. Would you use get instead of the square brackets in case the coordinates are not in the dictionary? Yes, that's a good idea. We probably should, well, at a bare minimum, we should definitely handle that case for sure. I don't know, do dictionaries have a get function? I'm not familiar with the get function, but if that is a way to do it in dictionaries, that's one way to do it. The other thing we could do is just make an if to check if it has that key or not, basically. But yes, we should definitely handle that. That's definitely something we do want to do. And also, hey there, Flavioff. Thanks for tuning in, and thanks for the suggestion. So let's open this up. Layouts, grid layout. Let's take a look at our new function here. Let's just level set some things. Let's print the cell coordinates. Let's make cell coordinates. Make sure those look fine. Maybe we could also print the entire dictionary. Let's print self.cell dictionary. Let's start with that and see where that gets us. So you can open the serial console right here. This will open the serial console to the device. One of the things I like to do though is use TIO. That's a terminal serial connection program. It's really nice because it does automatic connecting and reconnecting. So I'm going to use that TIO. And you know what? I'll use it. I'll just use it inside PyCharm. There's already a terminal in PyCharm. Do we want that? No, actually, I think I want the terminal outside today. Let's do it outside. TIO/dev/tty. And I happen to know this is going to be where my device is at, ACM0. You could do ls, you could figure out where it's at. There's also a way you can look it up by device name as well. I think Scott showed that recently. So we want to rerun this code, so we can either like update the file and save it again, but we can also use Control-C to go to the REPL and then Control-D to make it run again. So here we go. So we got our dictionary. The dictionary looks pretty good. We got our coordinates that came passed to us. That looks pretty good as well. Dictionary has no attribute text. So maybe we're not fetching... Seems like we're not fetching the thing out of the dictionary for some reason. Oh, you know what? Let's get this big. Cell content. So let's just look through the logic here. We passed the coordinates into the dictionary. Why don't we also do, instead of printing the whole dictionary, let me swap the order of these. Let me put this one second. Whoops. Let's grab that, cut, paste it, and let's go like this just to make sure that our index is coming out correctly. Save that. We'll look at our serial. So we got the index of 2, which makes sense because that is the third item we added. And remember, we're 0 based here. So 2 index is the third item. So that seems fine. So let's look print the content list. And let's print the whole list to start with. Ah, yes, okay. So this list, it does not contain the content directly. This list actually contains a list of dictionaries. Each dictionary item has a cell size and a content and a grid position. Yeah, so we want to get the content out of that. So essentially that error is telling us, hey, you have accessed a dictionary and then tried to access the text property of that dictionary. And of course, the dictionary doesn't have a text property. What we want is actually the label object in this case, which we need to actually get out of that dictionary by using content. So we will say we don't want to return content list itself. We want to return content list, the item that came out of it, which is a dictionary, and then we want to get the content key from that. And we don't have an error anymore, so I think we might be good now, actually. Yep, there we go. So now we have successfully changed this lower left label here to say day. So this is working how we want. So let's go ahead and use, let's go ahead and do what Flavioff said. We want to be able to fetch content out of this if, well, we want to be able to handle it gracefully if we try to fetch content, but the user passes us some bogus cell coordinates that don't exist. So to start with, let's just test that out. We could take out these prints now. Yeah, for sure. For sure. I like to show the process of working through this stuff because it helps folks. You know, a lot of the folks that use CircuitPython are new, newer to programming. That's one of the best things about CircuitPython. It makes it super easy for folks that don't have a lot of programming experience. So I really like to show the process of working through this stuff to let folks know, hey, even folks that have been programming for a long time, like I've been programming for, almost a decade now as a career, even folks been doing it a long time are still making mistakes, and debugging and troubleshooting is just part of the process. Yeah, for sure. I agree with that too. I like to watch folks on Twitch working on stuff. It's definitely nice to throw on the in the background there. Let me check on something real quick over here. Okay. Get the chats back and then we'll keep going. Alrighty. So let's test it out by giving it a bogus coordinates here. If we said like 3-3 maybe, there is no 3-3 in our thing, so let's see what it does. My guess is it should crash probably. Yep, we got a key error on 3-3. So let's look up at that Git. Let me see if that Git exists on dictionaries in CircuitPython. So we can use the REPL to do this. Another really nice thing about CircuitPython, there's a REPL right in here, just a live executor that will execute the code for us, or interpreter, I should say. So we can just test this out, right? We can say D is a dictionary, and then we can say dir on D, and it will show us all the functions. So there is a get function, and I'm not actually familiar with it. I didn't know about that. So what does that do? If we say d.get and we pass it an index that doesn't exist, like we don't have a hello key, it will give us back, it looks like none or nothing, basically. It gave us back nothing. So I think we want to get back nothing. I think we want to check if it exists. And then if it doesn't exist, what should we do? Should we return nothing? Or should we raise an error, maybe print a message or something? I almost think we should probably raise an error. I think we should try to raise an error, but make the error text as helpful as we can to the user. Because if we don't raise the error, then the next thing that's going to happen is, in this code, it's going to try to access .text, which I guess is probably also going to raise an error. So on our dictionary, if we were saying .get instead of using square brackets, then, well, actually, it's not even going to make it to the .text, right? It's going to get back nothing. It's going to try to pass nothing into the list, which I guess is going to be an index error, something like that. Let's save that, and it'll rerun as soon as I break out of the REPL. Yeah, we got a type error this time. List indexes must be integers. I think let's make an if statement that checks if it's in the dictionary or not. I like that. I'm going to switch this one back to square brackets for now. And I'm going to say if, I think we can just say if cell coordinates in the dictionary, then return it. Else we can make a new error, but we can make it have some text that's more helpful. We can say raise. We can make it a key error still. I think that makes sense. Key error. But we can give it some custom text. Let's make it say cell. Let's see. Grid does not contain cell at coordinates, and then we'll show them the coordinates they put. Format cell coordinates. There we go. So it is still going to make an error, but the message that it prints will be much more specific. Hey there, Johnny. How's it going today? Okay, so let me switch this here, and I'll put this one over here. I guess that's going to get covered up by the chat a little bit, though, right? Let me make it smaller, maybe. We can go here, but smaller. Looks like got to break it out from the side view there. About like that. I think maybe that'll get it not quite covered up by the chat. Oh, a default value. Okay. So if we wanted it to like return a different index instead, we could pass it a default value. Let's see here. So let's test this one. Oh, in fact, actually, I already saved it and it already ran. So here's our error right here. It says key error grid. You know what? I'm going to call it grid layout just to be even more specific here. Grid layout. Grid layout does not contain cell at coordinates 3, 3. There we go. That's a nice, helpful error message. If somebody were to be writing a program and they were to get this error message, you know, they will hopefully know what that means at this point. They'll know that they tried to access some coordinates that don't exist. So that might be all we need for this. Let me look back at the issue real quick and see if I mentioned anything else when I made it. I was the one that made this issue. You know, sometimes you work on issues that you make, sometimes you work on issues that other people make. But I left some details here that talks about it. We did say that we want to be able to change the color, so why don't we test changing the color as well? I think it should work the same, but it is good to test that, especially because that's the test case I put in the issue here. So back in my CodePy, I will go back to doing some of this. Let's actually change some of this. We're accessing by index still here. Let's change those lines up though. Let's go and use our new function. Get cell, so let's go with the first cell, 0, 0, top left, and then top right. So remember, this is columns and then rows, so 1, 0. And why don't we change these up a little bit? Let's go happy circuit. This one will be first column, second row, so 0, 1. Circuit Python. Let's do one more. 1, 1. Day. Let's save this and make sure it works, and then we'll also do a color as well. There's my device. We're going to save that. There we go. Okay, happy CircuitPython day. That looks like it's working. So let's change a color also. Maybe we'll change 2 colors. Let's set some colors on these bottom 2 down here. So we can just access them again using this lookup here. Nice. Yeah, Funhouse is a fun one. Oh yeah, we'll do. Hey, thanks Flavov. Flavioff. I'm not sure if I'm pronouncing your name wrong. Forgive me if not. Let me catch up on the chat here real quick. Oh no, we lost the football. Canada plays football. Yeah. Grass hockey. That's a good one. Okay, let's change the actually the background color. We'll test the foreground color as well. Let's start with the background color. Background, I think it's like this, background color. And I'll set them to like the opposite of these two. I'll put green behind Python and purple behind day. And so I don't know those color values off the top of my head, but we can look back up here and just copy paste them. So it looks like this is the green one. I'm going to duplicate that line with Control D. And let's save that. Yep, that looks like it's working pretty good. And I'll test changing the color of the text as well. I kind of like the looks of this, so I'll probably switch it back afterwards, but Let me just test changing the color as well, since that is what was in the issue specifically. So let's go one more here, and let's do yellow. So yellow is going to be, let's go like bright yellow. Max red, max green, no blue. That should give us yellow, I think. And let's do it on both of those those bottom two there. Do it like that. No. Oh, I did background color again. I did background color. We want the text color, which I think is just dot color. So there we go. Let me, I think, can I zoom in a little more? Yeah. Can, and then maybe I can scooch this so that it's not getting covered by the chat there. It does wash out a little bit. You can't see the yellow all the way unless I cover up the light, but it is turned yellow there accidentally. We'll save it. It'll rerun. And of course, yellow is actually a little bit too close to white, so it does also wash out. But if I cover up the light a little bit, you can see there that the text is now turning yellow. So that looks good. I think I do like this code with white text a little bit better though, so I'm actually going to erase that. Hey there, King or North. Thanks for tuning in. So this is good. I think it would be good if we include this as a library, as an example, a new example in the repository. That way folks can look at the example and know how to use this new functionality that we're proposing here. So what I'm going to do is actually just copy all of this code. I'm going to make a new example in the library. %, files not covered. I must have turned some kind of test thing on. I noticed these all say like a percentage and covered or not. I don't know how or what I did to do that. Hopefully that's not going to do anything weird when I go to push. You know, the other thing I should do before we get too far along here is make a branch for this PR. But I'm going to make the examples. Luckily, PyCharm is got tight integrations with version control. So even though I forgot to make a branch when I started, it'll still let me do it after the fact. We want a new Python file. We use these naming conventions here. So we always name our examples the name of the library, DisplayIO layout, and then this one's going to be grid layout, and it's going to be git cell test. So it's kind of a long name, but it's very descriptive. It tells you exactly what's going to be inside of it. I will hold off adding it for now because we do want to make a branch. Let me do that. Let me check the remotes, get remote -v. So we have the Adafruit remote. We want the Foamy Guy remote though, because we're going to push it into my clone of this repository first. So we want to go git checkout -b. We want to make a new branch. It's going to be called git cell, short and sweet. And we want to start it from Adafruit main. You know what we want to do though is we want to fetch, actually. We want to make sure we have the latest version of main. Git fetch Adafruit. And I'm also going to pull, I think. I don't know if that matters, but I like to do it. So I'm going to update main. Now we can make a new branch. Git checkout -b. The name of it, git cell. The branch we want to start from. So we want to start from Adafruit main, but we don't want to track Adafruit main because I want to push it to my own clone, to Foamy Guy's remote. So we'll say no track. Check that out. Okay, we got our new branch, git cell. You know, again, one of the nice things I like about PyCharm, it updates this thing down here that tells you what branch you're on. You can also switch branches from here, so that's really nice. You can do merging and all sorts of things. So we have our branch. We can add this example. So in PyCharm, it happens to be Control-Alt-A to add things. So I'm going to do that. You see it turns green, which is really nice. Lets us know that it's been added, but not committed or anything yet. It's still green to show that it's not committed. I have these two red ones here. That's showing that those are not actually added. Probably because I maybe made these examples, or these are extra examples that are not part of the repository. So we're not going to add those, but I'm going to leave them there. We need to do anything else? You know, I think we edited the code. Whoops. Yeah, Moo does this sometimes. If you leave stuff highlighted and you Alt-Tab away, it likes to erase it from you, but you can do just Control-Z to get it all back. So I think we modified the code in here. We added our error. We fixed up that dictionary problem. So I'm going to copy all of this code. We're going to put that back into the library in PyCharm. I'll just erase everything and repaste this. You know, the other thing we should do is provide a DocString for this function. Function is working good, but we want to have some nice docs for it. So we will make a DocString. This will say return a cell's content based on the cell coordinates. And the parameter is cell coordinates. It is a tuple. The coordinates to look up in the grid. It returns the DisplayIO content object at those coordinates. Or we want to put raises an error here. Maybe we'll put it here. Raises key error if coordinates were not found in the grid layout. Okay, so now we have a docstring. That's really nice because this docstring is what powers the Sphinx documentation. So I talked about these files here in the docs folder a little bit, and they end up going to read the docs. And so these actually get built from the docstrings like this. So the way this works is there's a command, a Sphinx command that you use to run this. We also need to run Precommit. Let me run Precommit as well. Precommit is just a tool that runs a bunch of other checks. It runs pylint, it runs the black code formatter, it runs a check on the licenses to make sure we have the license files built correctly, and all of that stuff. So we're going to run Precommit. Probably pylint and black are the main two things it's going to do for me today. Precommit run, is it all files, I think it is. You can set it up to be automatic. You can make Precommit just run whenever you try to make a commit. And I don't typically do that. I usually just run it manually. But so it did run black, which means it will have edited this code a little bit. You can see here it added some extra new lines and stuff. So the black code formatting changed up our code just a little bit, but it should not have changed the functionality. So if we copy this back to our device, you know, it should still behave the exact same way. Interesting. Happened to our camera. There we go. Scroll that there. So I'll save this. It'll reset the device there. And we see it is still working the exact same way. So that's all good. And it shows that it failed Precommit because black changed the code. So what we can do is we can actually just run Precommit again, and what we'll see is that this time the black will pass. So now it says passed here because black already changed the code. It doesn't have to change it again. So the next issue that we have is pylint. Pylint thinks we did something, or Pylint thinks we could do something better. So it says here, this is another really nice thing about PyCharm. It will linkify these lines of code right here. I can just click this and it moves my cursor right to where it's at here. So this says unnecessary else, because if this was true, then we return here. If that was not true, then we just continue on. So technically we could actually take out this else and the code will behave the same way. We do need to fix the indentation though, so I just did a shift tab there to indent it back. Because if this was true, we already return, we stop executing the code. So, technically that else was not actually necessary. This will actually work the same way. Pylint wants us to do it that way, so let's make that change and run Precommit one more time. Okay, so that's running on the library code it passed. It's also going to run on the example code. Oh, I did not paste the example in. Let me do that. So we'll see if this passes or not. It might complain this is an empty file, I guess, probably. There are quite a few examples in this project because of the way that it contains some other widgets right now. Now, it looks like it passed, but it is an empty file, which we don't want. We want to take our CodePy that we wrote here to test this out. We want to put that right inside the test that's in the examples directory, save that, and then just one more time, we're going to run Precommit. We can check the copyright. In this case, it looks correct. It has my name. I wrote it for Adafruit. Probably black. Yeah, actually black failed again, most likely because it wants space here, I'm guessing. Yeah. So I clicked my cursor back in here and it sort of caused this file to reload. So black made some changes when this ran. And it changed the file, but in PyCharm, until you give it focus, it doesn't reload in the screen. So we could actually cancel this early because we know we failed Precommit, but we're just going to run it right again because black did go ahead and make its changes. And so we see there this time it passed. We'll let it do Pylint again, and then after this, we will build the docs. And in order for building the docs, there's a special command you run. I don't know why this is killing the camera over and over again for some reason. Maybe it doesn't like to be zoomed in how I had it. Is it live? It's not live currently. Maybe I'll go back to the zoomed out version. That's live, okay. There's a command you run. I don't remember the command off the top of my head. I actually have an alias set up. I run Linux and I have an alias set up for it. But for folks that might be new, I'll pull it up. I happen to know there's a place you can find it. If you go Learn Guide, I think it's like sharing. Yeah, sharing a library. You can see I've searched for this before. There's this Learn Guide right here, creating and sharing a CircuitPython library. This is a hugely great beneficial resource if you are going to contribute to the project. This will explain, everything about Black and Precommit and Pylint, all the stuff that I've been using. It'll explain how to do the GitHub stuff if you're not familiar with it, how to make a branch and commit it and push it and all that sort of stuff. So I reference this all the time. And I happen to know there's a page here about Sphinx, I think. Read the docs right here, sharing docs on Read the Docs. So it tells you what you need to install, and it tells you this command right here. This is the command you run to build the docs. So you can see it's got a bunch of flags and stuff. This is why I don't have it committed to memory, because of all these flags. But this is actually the command. I'll paste it in the chat for folks if anyone's interested in this guide. I'll go back to the main page of the guide maybe. That's a really great guide if you do want to help contribute. I'm going to run, I have an alias for it though. So instead of running that command, I actually just have it set up. I can run cp docs. We do need to be inside the docs folder. So I'm going to go inside docs, cd docs, and run cp docs. So that's going to do its thing. And it looks like it was successful. It says build succeeded. It created some HTML files. So let's go just double check, make sure our DocStrings showed up correctly. So inside HTML, it is, so it's build HTML and it's this index. So we're going to open that in the browser. And I'm just going to drag it in. And so what we're going to do is go find grid layout and make sure our new function shows up. And there it is right there, get cell. So this is what Sphinx does for us. We wrote that DocString, and it actually like converted it into this nice, pretty looking HTML documentation here. So that's the name of our function. There's our parameter. Tells us that it's a tuple. We could actually click on tuple and go and learn about what tuples are if we don't know what those are. So that's really cool. And it filled in all the stuff that we talked about in our DocString. So that is looking perfect to me. So I think we're good to go here. We already created the branch. I think we're ready to push it. Just run through a quick mental check. We ran Precommit, which had black and pylint. We made sure the docs built. Docs contain our new information. Yeah, I think we're ready to push this. So in PyCharm, the way you can push it is Control K for commit. I don't know why it's K. I guess, well, Control C is already used, right, for copy. So maybe that's why they chose K. If we update the alias, cpdocs. Oh. Interesting. That's cool. So we could run it from the root directory. That's a neat tip. Hey, thanks for that, Lay Samurai. I think I'll hold off for now, but I probably will end up doing that because sometimes I forget to go into that docs folder. And so that would be nice to be able to do it from the root because that's where the terminal, at least inside of PyCharm, that's where the terminal spawns by default. That's a good idea. I didn't know you could specify the directories there like that. As guess those are just arguments on the Sphinx command. That's really cool. Another one of the things I really like about PyCharm is it gives you these differences. So I'm just going to look at the differences to make sure that I did not accidentally change anything that that shouldn't be changed. So it highlights them like this. They're nice and super easy to see. So we added a cell dictionary. That makes sense. We added items into our dictionary inside of the add content function. That makes sense. That's just changed right here. We added a new function called getCell. Of course, that contains all of our new code, including the DocString. So that all looks good to me. The example, of course, is all green. There was no old version of this example because it didn't used to exist. Hey there, let's see, Manolia Meow, I think maybe is how you pronounce your name. Thanks for the follow. I appreciate that. So this is all green. That's looking good. Of course, it's all green because this file didn't exist before. So this is a brand new file. Oh, you know what I noticed? We should actually fix this. We should fix this test here because this actually does a little bit different now. And let's make this say green and purple rectangles. And then let's put, and then update the color and text values of the labels using the getCell function. There we go. That way this is more specific about what the example is. So, you know, that's why I really like to look at these things in the change here, because sometimes you spot stuff that you should have done, but you didn't, and then you get another chance to do it before you have made the commit. But I think we are actually good now. So we need to choose a commit message, adding getCell function to grid layout. That seems pretty good. And in PyCharm, I think you can do Control-Alt-K. Will basically finalize the commit and get it ready to be pushed. So we want to push this. This I've noticed before, even though I've been using that no track command, that no track argument on the checkout that I did, sometimes this still tries to default to Adafruit. So we actually want this to go to FoamyGuy. So I'm just going to change it right here. So getCell, this commit is going to go into FoamyGuy getCell. So that's the new branch it's going to create. It tells us it's a new branch right there. We could, if we wanted to do one last triple check here, we could actually look at these differences again, which I do sometimes. Again, because I just like to, make absolutely sure everything looks good before I commit. Although sometimes I still miss stuff and then make new commits, and that's okay as well. We get to see all the changes. These are all the changes that would have happened since the last time I updated my remote. And in this case, this latest commit right here, this is the one we made today, but this one is an older one, right? This contains some other code. I just never happened to pull this one down here into my clone. So that's why it shows up in this list. But that's all looking good. We're going to push it. And so now back on GitHub. GitHub's really nice. It will give us this thing right here, which it knows that we just pushed this less than a minute ago. And it prompts us to make a new pull request from it. Of course, we could, if that wasn't there, or if we didn't want to use it, we could go to the pull request page. We could say make a new pull request. We could fill in the branches here. I could go find Foamy Guy. But this button makes it nice and easy. I can just click this button, compare and pull. It will check, it will find the right branches for me right here. And so this makes it nice and easy. So it says we're pulling, from Foamy Guy, and then get cell branch. We want to, make a pull request to move that into Adafruit main. So that seems good. We can just leave a message here that says what it does. Adding a new get cell function. Let's put that in code. Code wraps like this. That allows you to look up cell content objects by their coordinates within the grid layout. Added a new example to illustrate this functionality. And also, since there's an issue for this, I am going to put resolves. This issue happens to be number 43. So what that's going to do is it's going to make this linkified right here, and it's also going to tie the PR to the issue so that when this PR gets reviewed and merged, it will automatically close the issue, which is really nice. So again, we do have the chance here. GitHub shows us the differences as well, so we can real quick run through the changes again with this nice pretty highlighting. Just make sure everything is looking good on this side, which it does look pretty good to me. So we'll go create pull request. And there we go. We created a new function. We created a pull request for it. So now we just wait and somebody can come along and review it. And then if it is looking good to the project maintainers, then they will be able to merge it into the library, and then it will become part of the library that anybody else is allowed to use. If folks are watching, and if you are interested in getting involved, you could come review the PR. That's one of the ways you can get involved, is you could actually come to this PR page here. You could try out the new code on your device, or just look over the changes here. See if there's anything you think we should have done differently, or if you try it out, if you have trouble getting it to run or anything like that, then you could, paste a review onto this PR here and let us know what you thought. So that gets us through the first one of the issues. I'm going to work on the second issue that's created here next. This one says, it'd be nice if we could provide a way within the grid layout to let the user enable functionality that will draw lines between the cells in the grid layout. The most basic implementation could be just on or off with lines between all the cells, but a more advanced implementation could allow the user to specify that they would like lines between only certain cells, and they would have to pass some kind of parameters to specify which ones. And then we go on to say here that, that would give them the ability to group certain cells together. So this was an idea that came out of a project that Kattni was working on recently on the macro pad. It was set up, the macro pad is this device here. I don't have the code loaded up for it, but I can show you kind of, if we use our imaginations a little bit. Kattni wrote a program that runs on this macro pad right here. This is a screen, and ordinarily, by default, this device stays in this orientation like this, portrait mode. but you can actually rotate it as well. So Kattni made this program that runs in landscape orientation like this. And essentially what it does is it groups the rows of keys, like 1, 2, 3, 4. It groups them together as a cell of like a 2x2 section. So 1, 2, 3, 4. The next row is below that. So 1, 2, 3, 4. And then the next row is below that. 1, 2, 3, 4. And it does use this grid layout. So the grid layout helped to line all those things up in the right space. But, when Kattni made that program, she came to me and was like, hey, is there a way we could draw lines in between those sections so that we could have the 2x2 that represents the top row and then a line, and then the 2x2 that represents the middle row and then another line, and then the 2x2 that represents the bottom row. That way they're visually separated by those lines there in between. And so that's basically what we're going to try to do. I am going to start with the basic functionality though here, which is basically just on or off. We're going to provide a way that draws lines between every cell in the entire grid, because I think that's going to be easier. And then once we've done that, then we can start working on how do we pass in parameters to specify, like, we want it only between certain cells and not between everything. So the way we're going to make the lines right now is going to be using this DisplayIO shape module. There is another module called VectorIO. To give a quick shout out to Warrior of Wire, that's the person who worked on VectorIO. This is the main repository for CircuitPython, and there's a PR here for this. And so Warrior of Wire has worked on some updates to the VectorIO module recently. So changing the way that the API works a little bit. In this case, I do happen to know, I think Warrior of Wire mentioned that it doesn't support the rotation still. I think maybe the sample code, yeah. The sample code, it says the rotations don't work yet. So, that's going to be a fix that's coming sometime in the future. And, I happen to know that for this use case on this macro pad here, we definitely want to be able to use the rotations. So I'm actually going to use DisplayIO shape for now. But VectorIO, I think, is actually a little bit nicer. I think it's a little easier to understand how it works. Shape is cool, but it has some weird quirks that you kind of have to get used to. And so eventually, probably we'll change this over to VectorIO. But for right now, we're just going to use shape. And shape does also work in the rotations. So shape will let us do that when it's rotated to that, landscape mode there on the device. So I'm going to make a new branch to start this next feature. So this is in the same library, of course. We're working on grid layout still. Go back up. Let's go checkout -b. New branch. This will be called divider lines. Divider lines. And we want to start from Adafruit main again. Do our no track. Okay. So now we have a new branch ready to go. I'm going to go back inside grid layout here. I really wonder what I did to turn this on. Is this in every project? I open a different project. No, it's turned off here. Let me see if I close this, then reopen it. Will that stuff be gone? Yeah, okay. I like that better. I don't like those things. We don't necessarily have, that's talking about automated tests, I'm pretty sure. We don't really have automated tests that cover 100% of the code, so that stuff is always going to stay there if it shows. So I'd rather just get that out of the way, and I have no idea what I pressed to turn that on. I could probably look up online PyCharm, shortcut test coverage or something. I probably would find it, but turns out just closing and reopening worked, so that's nice. We'll clean this up. Let's close everything besides grid layout. And let's see, I think we want, how do we want to do this? Do we want to provide I think we want to provide a parameter when you create the grid layout. Just think through that. Yeah, I think we want to have a parameter when you create the grid layout that will be a Boolean that says on or off for the divider lines. Divider lines. So we can just go ahead and start working on the DocString as well. This is going to be a Boolean. I think, do you do bool or Boolean? I'm not sure. Let's see. Divider lines. Probably just supposed to be bool. Here. And this is going to be whether, that's the wrong kind of whether or not to draw lines between the cells. Okay. And we can, I think, set that into a private variable so that we can access it inside the other functions. Divider lines. Oops, you know what? I have hidden the chat accidentally. Let me bring that back. Run with code coverage, I see. Okay. Divider, we want to set this to the value that was passed as a parameter. And next, we want to, basically, we're going to be making some modifications inside layout cells. This is the function that's responsible for doing all the math to measure things and draw everything and add it to the group. Because we extend group. Grid layout extends DisplayIO group. Group is one of the basic building blocks of DisplayIO. You can show a group on the screen. You can add multiple items into the group. So grid layout actually is a group. And let me just take a quick look at how this works. So for instance, when you call add content, it adds it to the cell list. And then it calls layout cells. And of course, in that new version that we just wrote a moment ago, it will also add it to the dictionary. But I started this branch from Adafruit main, so it does not contain that new code yet. One thing I'll try to keep an eye on as well is whether or not the actions completed successfully. Because if those actions did not complete, and it looks like they did. Yeah, we got the green check right here, which means the action's completed. Thank you, Flavio, for leaving this review here. Yeah, we can leave. Thank you for putting the link in here so that folks can kind of see the history of this. That's pretty cool. So this did pass actions, so that's good. If that actions had failed, if that was a red X or something, then we could go back and see, what caused it to fail, and we could fix it up. So let's see. So we're always appending things when we call. I see. Okay. Yeah. When we call layout cells, let's just kind of step through the logic here. This says for each cell in the cell content list. So we're looping over all the cells that are in the content list. We're checking whether or not the current content item in the current cell is already in the group or not. So if it's not in the group, then we are executing all of this code here. Else, if it was already in the group, then we are setting the width and height and then measuring out the values that those need to be based on how many things are in the group and what size the table is and all of that sort of stuff and the padding. So if it was already in the group, we do this part. Then we set the XY location. Did we find a logic error here? I feel like I feel like we're adding extra things to the group, are we? Because we're looping over all the things that are in the content list. This is checking if it exists in the group or not, and if it's not in the group, we would want to add it to the group. But let's go into the else down here. And I think we would not want to add it to the group if it's already in the group. So I wonder, we might be adding more and more copies of the thing to the group. Let's do some testing and see if that's the case. We could just bring back this example again. In Mu, if you leave it highlighted, I had this all highlighted with Control A before, and you Alt Tab away. Sometimes it likes to erase your code, but you can just get it back with Control Z there. We can just keep checking the length. So why don't we after we add the first item, print items in grid group. This will be the length of layout, because since layout is a group, and group, underneath the hood, the group behaves like a list at this point. So we're able to get the length of the list essentially. And we just want to put this after a couple of these. And so if things are working as intended, then we should only end up with 4 things in the group at the end. But if things are getting duplicated, then we'll end up with more than 4 things. Here we have a main group, which is what we ultimately show on the screen. Okay. We'll scrunch that just a little bit. So let's save this. No, we only have 4 items in the group. So it's working as intended. But why? Self.append. I'm a little confused. Why? Is something removing it from the group? We have like a del or remove? No. This is outside the for loop? Is this outside the for loop? No. Does a group, does it automatically stop you from appending the same thing twice? So this is a little bit aside from the specific problem we're trying to solve. But I am gonna explore this a little bit more because I am curious why it's working like this. We do have about 40 minutes left, so I don't know. It's possible I may not make it all the way to get done with the grid lines. And if that's the case, maybe I'll work on this on my next stream. Self.append. Let's do a little bit of an experiment here. Let's grab the simple test from the DisplayIO display text library. I'll just get it from GitHub. This is a real nice, just super duper basic DisplayIO test. So this one just creates one label and adds it to, well, it's actually just showing it directly on the display. So it's not actually making a group. We're gonna make it make a group though. Main group is a new group. We want to show main group, and we want to append the text area to main group. Okay, we'll run that. Of course, I switched these out. Let me put the PyPortal back. Group is not defined. Yep, we need to import group. Import group. Okay, so we have our hello world. And now let's go print length of main group. So that should just print 1, which it did. And now what happens if we just try to append it again? Do we end up with 2? Ah, okay. Layer is already in the group. So it raises an exception. So are we must be catching that exception? We accept an attribute error. We don't ever catch that error, though. And add content definitely calls layout cells. So each time we call add content, we will always call layout cells. So layout cells is getting called 4 times in the case of that basic example we've been working with. The first time it gets called, the content list contains a single item. I'm just going to step through the logic here. The first time it gets called, this has a single item. Cell gets set to that item. We check if content is in self. At this point, it's not, because this is the first time we've come through here. We will set some variables for the grid size X and the grid size Y, grid position X, the grid position Y, button size, which this should probably actually say cell size instead of button size. Shout out actually to Kmatch. Kmatch98 is one of the community members. Kmatch is the one that wrote the code that ultimately became this grid layout. And when Kmatch wrote it, it was an example and it dealt specifically with buttons. And so this is kind of like an artifact from that. At some point, we should actually rename this to say cell size. So if somebody else, again, if somebody else is interested in getting involved, you know, this would be a relatively basic, like a good first issue type of issue, would be renaming these variables to use cell size instead of button size. But because when he wrote it, when Kmatch wrote it, it was specifically, it had buttons in it, but we generalized it so that it can hold anything. And so that's why this says button here, but it's setting the cell size. So if the content atom has a function called resize, then call the resize function. Else, if it does not have a resize function, then try setting the height and width independently, setting the height and then the width, one after the other. And if it does not have height and width, if it doesn't allow you to set those, then we just pass. We just allow it to be whatever size it is. Next up, we set the X of the content item by doing the math to figure out where it should be. Then we set the Y of the content item, same thing, and we do the math to figure out where it's supposed to go. And then we call self-append cell content. Ah, okay, I get it. I get it. I got confused here. We have this inner else, or this inner if here. This if is saying if it has attr resize, and I got confused before and I saw this else block and I actually thought that it matched up with this, but it doesn't. So all of this code, including this inner if else, all of this is all wrapped inside of this right here, which says if the content is not in self, then we execute this code. Otherwise, we actually do nothing. There's no else block, so it doesn't do anything, which means that it doesn't ever get appended. So that is why. Okay, the world makes sense again. We can get back to our grid lines. Sorry to go on a little bit of a tangent there, but I wanted to make sure that that was not going to be creating a problem. Yeah, and the way the indentions work here tricked me up a little bit. Made me think that this was outside the if, but that makes total sense, actually. Okay, so back to our grid lines. So what we want to do basically is, let's see, do we want to do it after? When do we want to do it? Let's see, when do we want to add the lines? We would want to add them. We would want to add them like as we add items, I think. Yeah, I think we would want to add them as we add items. So let's start by trying to draw a line below each item as we add it. That seems like a good place to start. Of course, we'll have lots of other work to do, especially if we want to eventually support, choosing the cells that you add the lines to or not. But we always, in programming, it's always good to start super basic. Get the very most basic functionality working first, and then start working on adding on the rest. I'm going to plug in my macro pad. I think I have sample code on the macro pad that draws lines with shape. And I don't just remember off the top of my head how to do that. So, another thing, even folks that have been programming a really long time, it's always good to just refer back to other code. Like if you've already written something before, there's no sense necessarily in just trying to write it with brute force again. Looks like, though, I was wrong. I don't have anything like that on my macro pad. Maybe I put it on the PyPortal and I just forgot. Let me unplug that. And let me get this wire up out of the way here. Let's take a look at some of the other stuff on my macro, or on my PyPortal here. So something with shape. Let's see. There we go. Let's look at this one. Yeah. This is actually a pretty advanced example of shape. We don't need it to be quite this advanced, but this will be a good starting point. So I'm actually going to take this code and I'm going to modify it up a little bit to make it just draw a line. And then once we have our code that draws a line, then we'll put it inside the grid layout library. I'm not going to mess with the mirrors for right now. I'm going to set those both to false. Theoretically, we could maybe use one of these mirrors to save memory, possibly, if it works that way. I'm not actually sure if that saves memory or not, but these allow you, like, you could make the shape half the size that you want it to be, and then you could set this mirror to true, and it would, like, unfold. I like to think of it like origami unfolding is kind of how this thing works, but to start with, I'm just going to keep it super basic. We're not going to do anything with boundary. We want our line to be only 1 pixel tall. I'll just leave it at 100 for now. So we create the shape, 100 width, 1 height, no mirrors. We have a palette. Let's make it white because we have a black background. Creates a tile grid. We put the shape on the tile grid. This is very common. Commonly how things get added to DisplayIO is you create like a bitmap or a shape or something, right? You create one of these objects, and then you have a palette which defines the colors, and then you combine that object you created, whether it's a bitmap image or a shape in this case, or like a vector shape if you're using VectorIO. You combine that together with the palette by putting it into a tile grid. So we can see here the tile grid accepts the shape, and it also accepts the pixel shader, which is our palette here. I think index 0 will be the foreground, so we'll leave that. We might not even need an index 1, I'm not sure. We'll leave it for now. We create a group to hold it. I think it's best not to call groups group, honestly, because it gets a little confusing since that's the built-in name. Let me just check this real quick. Nice, it's a good thing I checked. This was my my wonderful wife offering to get me a coffee, which I'm definitely down for. Here we go. Okay. Got the coffee coming. Yeah, so I think it's best to not name things group. Since group is the built-in name, I think it's best not to reuse built-in names. Even though, capital G group is the built-in object, and our variable was called lowercase g group, so technically it would have been fine, but I think it's best not to do that, even though I'm the one probably that wrote this code and I did it the wrong way. But here we go. We're fixing it now. Yeah, for sure. Let's give that one the coffee emoji, definitely. Boom, right there. All right. So this should draw a 100 pixel wide line that's 1 pixel tall, and it should show it on the screen. So let's give that a try. Yep, it's very close to the top of the screen, so it's kind of hard to see up there. Let me move it down some. We can do that by changing the X location, the Y location of the tile grid, which I think we could pass a parameter here. Y equals, let's just call it maybe 50 for now. Yep, that worked. And actually what I see is that it is teal. This line is not white, it's teal. So it may not come through so good on the camera. One thing we could do is actually, if I switch it to red, maybe it'll come through a little better. So my guess is actually that palette 1, yeah, there we can see it's definitely red there. So palette index 1 is actually the index we need to set for our foreground color. So I'm going to set that one to white. And there we go. Now we've got a white line. So this is exactly what we want to be able to do, basically. We will eventually need to probably provide a way in grid layout where you can specify the color. But for now, I'm just going to hard code it to white. So, because again, we always want to start super basic and then add from there. So let's say, let's see here. I think we should call this enabled, divider lines enabled. And I think we should keep a list of the actual lines. Yeah. This way we'll be able to reference those shape objects and possibly the tile grid objects. I think what I'll do is I'll set it up like this. This will hold a dictionary. It'll have a tile grid, and then this will be the tile grid object. Of course, it's it's not going to work here, right? We don't have the tile grid objects yet, but I'm just doing this to show what I'm going to do. and then it'll have shape, and this will be the shape object. And then we'll just keep adding these lines to this list, and then we'll be able to access them from the list. And what we'll do is we'll make sure to put them all at the end of the group. We'll put them after all of the content items in the group. That way, all that new code that we just wrote that's doing the lookups of the indexes and the XY coordinates, it will still work correctly because all of these will have higher indexes. So this is what we're going to end up with. And I think we want to keep them in a list like this because we need to redraw them whenever we add things to the list, just in case if the size changes or something like that, possibly. I even get my choice of what type of coffee. Look at that. Here we go. Alrighty. Thank you. Shout out, huge shout out. Thank you to my wife for bringing me coffee. That's amazing. Okay. So let's see. When we add a thing to the group, we're getting the width of the thing. So let's refactor this a little bit. Let's say measured width is equal to this calculation. Let's format that. Control-Alt-L in PyCharm will format the code nicely. Let's make a measured. You know what? We should make these. We should make these underscore maybe because they're private. Let's go measured height. So we're gonna make variables for these. Okay, and then now we can use those variables right here. So this we would pass in the measured width, and then we would pass in the measured height. And we can actually do the exact same thing down here, because this is the same measurement. We have height copied right now, so let's do height. Oh, nice. Yeah, thank you, Keith. Hey there, Carlos Elop. Sorry I missed your question there. But Keith is 100% on the money. Today is CircuitPython Day. There's a couple other streams if you're interested in this kind of stuff. There's more streams to check out. And yeah, I'm working on one of the CircuitPython libraries. So we're adding some new functionality. Let me copy this and drop it in the Discord here. I'll put a link here in the Discord if you are interested in watching some other streams today. Check out this link here. If you like this kind of content, specifically programming type content like this, one that I recommend checking out later today is Scott. Scott is the lead developer of CircuitPython. Let's see, do I have this pulled up still? I don't. Let me open this. This stream at 5 p.m. Eastern Time US. This is Scott's deep dive stream, and it's pretty similar to this. He was usually working on some programming code and interacting with the audience. You can ask him questions and do all that sort of stuff. So if this is the kind of stream you like, definitely check that one out. But the other ones that are going on today, I'm sure will be awesome as well. And thank you again, Keith, for answering that question. I appreciate that. Okay, so we created our variables. We're using those variables here. And now what we want to do is we want to make a line using that size. We also want to, if this passes, if we can't set the width and height of our cell content, then we're just going to use the size that it already is. That's what the comment right here says, which means we want to set measured width to, well, we want to be able to get the width. But This does not allow us to get them, possibly? Let me look at something in display text real quick. So I happen to know, just because I worked on this library, the layout, the grid layout, I also do a lot of work on display text. I happen to know that display text is the one that this applies to, basically. So are there accessor properties on display text? I think we did just add those recently, didn't we? Width. Okay, maybe I shouldn't have searched width. Label base, this is what we want. Yeah, there we go. We have accessor properties, okay. So that's good. So what we want to do is, you can access the width and height, but you can't change them on the display text. So we will set our measured width equal to the width of the display text in this case, which is stored inside of this cell content. We'll also set the height the same way. Yeah, for sure. It's a lot of fun. Carlos, it's really fun playing with the CircuitPython stuff. Height. Okay. So now we have the size. So I think I'll just put it down here. I'm going to go back to my sample code where we drew the shape, and I'm going to just take some of this code. We're going to get the shape here. Whoops. I'm just going to go ahead and add this to the that list we created. Divider lines. And pinned. We want it to be a dictionary. We're going to add the tile grid also. Okay, looks like I lost a parenthesis. Let's put that back. We have our height and width. It's going to be measured height and measured width. Okay. So now we need to make the tile grid. We also need to make the palette. I'm going to make the palette up here. Again, we're just going to hard code it to white for now, but eventually we will also try to add a way for the user to specify the color. Now we have the palette, which we need in order to make the tile grid. Maybe we should store these in temporary variables instead of just adding them directly, because I need to be able to reference this shape. Yeah. So let's go shape. Let's make them like this, though. Actually, we can call this more specifically bottom divider line. That's a lot more specific. Don't need the comma. We could let this jump to the next line how it wants, probably. So now we're going to be adding that here. We should, I guess, probably might as well do the same thing for the tile grid. Bottom divider tile grid. Okay, this is no longer shape. So now we have our shape object, which is our line, and our tile grid, which maps it up with the palette. We don't want this to just be 50, though. We want this to be the cell contents Y plus the cell contents height. So since we're going to need to have some more space here, I'm just going to go ahead and wrap this already to some new lines. Set of 50. This is going to say cell content Y plus cell content height. Or we already have measured height, I guess, right? Yeah, we can just use that. Here we go. Okay, so we have a line, we have a tile grid. These are going in the dictionary, so they need keys. I'll call this shape for now. Eventually we'll maybe call this line or something instead. I'm not sure. Tile grid. Whoops, we got caps lock on. Tile grid. Grid. Whoops. There we go. Yeah. Yeah. It's awesome. I come from the background of development. I've been a software developer for like close to 10 years now. Mostly on Android, but I branched into Django, Python Django, more recently to make web applications. And that's what drew me into CircuitPython, was being able to apply those, real basic Python programming skills to get into electronics and circuits and things like that. I played with Arduino and things like that before, but I never found it to be as fun. It feels more like work to me. It's kind of, fighting the battle against the C language and stuff like that was always a bit much for me. But Python makes things super easy, and so it was it's basically what got me into this stuff. Let's put our tile grid in. Okay. And we also want to append to self.append the tile grid we just created. So that's going to draw a line below each cell as we add them, I think, if everything works right. Let's try this out. Paste my updated version right in here. And eventually I think we'll need some logic to maybe remove all the old lines and recreate them or something like that. I'm not sure if we need that, but I think we might. So let's save this. And then let's get back to our grid sample code, because right now we have that line drawing sample code, which is not what we need. Don't need magtag for right now. Here's our examples. Here we go. We want grid layout. I'll just use the plain old simple test one here. So we'll save that. We got an error. Let's see what this says. It's missing a required positional argument. CodePy line 28, which I guess is probably the first call to. Oh, we made that. Yes, we made this. We made this required. We should say. By default, this is false. Yeah, we want this to be a keyword argument that's optional. If you don't pass it, then it's false. Also, we should be checking it, right? We're drawing the line right now, and we don't have any logic, but we should say right here, if that's true, then do this stuff. And I'm actually going to move this up. We're going to pin the content before we ever do the line. There we go. And I'm going to run this again. And what we'll see is actually that probably nothing is different, because we did not pass true. And we just added logic that says only do this if it's true. So let's do that now. Divider lines. True. Okay. we got something. We got these white blocks. Those are not quite what we want. Let's see what we did wrong. Can we get that thing to go away? Let's see. Okay. I don't know where I put that true. Hopefully that didn't, well, it didn't change the code though. It doesn't have a dot there, so it didn't change anything. So what do we do wrong here? Yes, we don't want to make this measured height. We want this to be 1. Yeah, that makes sense. Oh, here's, this must be where it put the true, I think. Let's put that back. Oh, and you can see there, it already updated. And it already saved, but the width is not quite right. But it drew some lines. We're getting closer. Let's print the width. Print measured width. Maybe we should make this actually line width format. All right, and we're getting close to time here, so we probably will not actually get this all the way working. But I definitely appreciate all of you folks that came in and watched along and hung out with me in the chat here on Discord and Twitch. And again, I'll just reiterate as well, there's some more streams going on today, so check out the link I pasted a few times in the chat. If you didn't catch it and you're interested, let me know. I can paste it again, but do check out the other streams. The next one that's coming up is, I think it's going to be with Dan, maybe, and Jeff and Katney. Is that right? Let's see. Just got rid of the link again. Let me check it again. So the AMA, also the AMA is getting ready to kick off as well. So head over to the Python subreddit if you're interested in asking questions to the core developers. And yeah, the next stream that's coming up here in just a few minutes is Jeff and Dan and Katney will be talking about CircuitPython. There's a YouTube link right here if you want to check that out. I'll definitely be watching along. Okay, let's look at what printed. Got a few minutes, let's see. 30. Does not seem like it's big enough. Maybe it's because... No, because we're not changing the text. Let's see. Print getting width from property. Nope. Getting. Doesn't really matter. We're going to take it out eventually, but. So we are getting to here. I wonder if we found a bug in display text. Maybe we should just keep the measured width we had. We already did the math. Maybe these are giving us the wrong values. Or it would be these, actually. Maybe these are giving us the wrong values. Let's comment these back out. We already have a pass right here, so this will just keep measured width and measured height the same values we calculated here. Let's try it that way. There we go. Yeah. So maybe display text. We might have just found a bug in display text. Possibly the width there is not representing the whole width of the label for some reason. I'm not quite sure. That'll be something that we can look into on a different day, though. Let's see. Oh, yeah. Thank you, Keith, for catching up on the chat here as well in the Discord. Yeah, the hardware I'm using in this one is the Adafruit Pi portal. That's what this device is right here. If you go to adafruit.com and you search Pi portal, you can find this device. I'll drop a link as well in a minute. There's downloads. Yeah, the downloads page is perfect. It shows you all the devices that are supported. I will drop a link to this one. And thank you, Carlos, for the follow there. I appreciate that. Yeah, thank you, Keith, grabbing that link. It's the PyPortal link right there. So one thing I do see is our lines are only drawing on the left side. It seems like we're not getting ones on the right for some reason. Maybe the Y or the X. I'm not setting the X value correctly. Yeah, actually right here we need to be setting the X value. Probably we could be setting that to this, I think, the content X. So where did that go? So I'll wrap up after this. Whoops. X equals, let's do this. Yeah, there we go. Now we got lines underneath both of the items. So that's perfect. This is pretty much what we were trying to get to. There is a little break here from the padding. Eventually, maybe we'll add the padding in so that we can take into account that. And then, of course, we'll also be making vertical lines. And we'll also be probably doing lines above it on the top there. But we got pretty good. We got the bulk of this, basic functionality out of the way. And so that's awesome. So definitely appreciate all you folks that watched along. If this is the kind of stuff that you are interested in, you can usually catch me on Saturdays at this time. Saturday, 10 a.m. Central. Honestly, I'm not 100% sure if I'll be streaming tomorrow. I do have some other stuff going on this weekend. And actually possibly next weekend as well. So it may be a couple of weeks before I get back. If so, I'll try to sneak some other ones in between. But generally, every Saturday at 10 a.m. you can find me here. And if you just come to the chat room, that same live broadcast chat room, you can usually find me there. I'll drop links. And it looks like Kattni put the link for the next stream just a few moments ago. So I am going to head out now and start watching that. Thanks again, everybody.